Oh hey guys, I'm so sorry that I can't be with you today. I would love to be, but I'm too busy sunning myself in beautiful London to be there with you. I wanted to still do my presentation though, because I feel like I've learned a lot since I've been here, and I really wanted to talk to you guys about health and safety, particularly talking about risk assessment. I have a saying that I throw around my classroom a lot, which is safety third. I don't really mean that, but I kind of do. By safety third, what I mean is we should be thinking about whether or not this is affecting the quality of life of the students that we're teaching first, more than whether or not it's something that needs to be worried about. If I feel that whatever I'm doing is going to have a positive effect on the education or the livelihood of that student, then that is, for me, a risk worth taking. And instead of thinking of risk assessment as something to do that's a burden, we should be thinking about how can we ensure that our students are being able to do the things that they should be doing in the classroom. There's a really dangerous experiment that I want to focus on because it's one that I had to do a lot of risk assessment for in order to do. It's called the Screaming Jelly Baby experiment, and it's one of the most dangerous experiments that we do here at Ashlands, and has a tendency to go wrong very frequently, as you can see from these videos.
Jelly Baby's going in now. Oh!
Did that get you?
Suicide!
Mo?
Whoa! Burnt out.
Hang on. We want to film his hole. Yeah. There it is.
Fair though, I thought she was faking her first. I thought she was a really good actor. I'm like, wow, that sounds so realistic.
Now go and film Stuart. Go and film Stuart's arm. Stuart, smile.
Hey, take this down. Smells like bacon.
So the Screaming Jelly Baby has a lot of what I like to call lemons. Lemons are bright yellow and they're very sharp. They're your really obvious hazards. They're the hazards that are there all the time and you can definitely see them. When we do risk assessment, we mostly only think about the lemons though. And that can be a problem because some lemons aren't obvious, some lemons are hidden. What we need to be able to do is look at all the different kinds of lemons that we have and try and minimize the amount of lemons that we have so that our lemons become less of a problem. I'm going to show you how I risk assessed the Screaming Jelly Baby experiment based on some of the obvious problems that I thought of, and then later on, after doing the experiment, some additional problems that came later. The main lemon for the Screaming Jelly Baby experiment is the potassium chlorate 5 that we use to do the experiment in, which is a really high or oxidizing agent. You can see the risk behind me here. The main risk with this is that it's oxidizing and harmful, and it can form explosive mixtures very quickly. It's because of this that it makes the experiment incredibly dangerous, as the molten sugar that we put into it in terms of the Jelly Baby can spit out, form an explosion, and cause a lot of damage to not just the lab, but to the students around it as well. It's incredibly dangerous, and for a while it was banned in schools because of the level of risk that it posed. Lots of teachers were doing this unsafely, and it meant that it was removed from the curriculum. It hasn't ever really recovered, as it still has a reputation of being a very, very dangerous experiment. But there's no need for that. It's just that people weren't following the lemons properly. If we give lemons respect, then those lemons will work for us. We need to make sure that our curriculums are stimulating, that they're exciting, and that they're interesting students into our subject. And by removing risk, what we do is we sterilize our subjects instead. We should try and make them exciting. We should try and make them interesting. So I'm going to show you how we can look at that in terms of the lemons of this experiment. Right, I want to talk you through my way of risk assessing now, which is super quick, enables us to think about exactly what the risks are and how to minimize them in a really quick way. And it's kind of fun to talk about lemons at the same time. I'm just going to go through a few of the lemons that we have to think about to do this Screaming Jelly Baby experiment. The lemon that I've used is, we're going to start off with the potassium chlorate 5. Like I said before, the lemon itself is going in your first column. What's the thing that makes it so dangerous? In the case of this, is that it forms explosive mixtures, it's oxidizing and harmful. The next step is that sometimes lemons end up becoming a chain of lemons. So if you've got one lemon, very quickly that can become a few more lemons, which will become more lemons, which will become even more lemons. And we need to stop a chain of lemons from happening. Potassium chlorate 5 makes explosive mixtures with sugar. And because of that, we need to think of a really safe way of doing this experiment, because what we're doing is putting sugar into potassium chlorate 5. We need to make sure that the explosion that's being done isn't allowed to happen. So we need to make sure that we're stopping that lemon chain from happening. I remember what I said about hidden lemons before. I just did some research and we went to a website called CLIAPS, who do a lot of chemical risk assessment. On their risk assessment, they actually have recorded any issues that have ever happened in an experiment. Now, normally what I would do if an experiment is really, really dangerous and has a high chance of catching fire to different things, is I'd probably do it in my fume hood. However, CLIAPS have said that a recirculatory fume cupboard has caught fire with this experiment. It appears that sparks were sucked into the pre-filter, which is made of paper. That's something that we need to add to our lemon chain. If I had done this experiment in my fume hood, which sounds like a good idea, it could have set fire to my fume hood, which would have increased the lemon chain. We need to make sure that we're doing the proper amount of research when we're looking at our risks. Not to mention there's another hidden lemon here. The next biggest hidden lemon is the fact that it produces so much smoke. There's so much smoke produced, it can actually be a very big danger to those that are asthmatic. So we need to think of the way of reducing the risk for asthmatic people. There's another interesting lemon here. If you use the sour jelly babies instead of the just coated with sugar ones, they're actually coated with an acid. And because of that, if you put it into the potassium chlorate, it makes a side reaction, which makes an incredibly volatile mixture. So we have to make sure that we're using the right jelly babies as well. If we were to put the sharp jelly babies in, it would create so many lemons. The final thing that we need to do now that we know what all the lemons and chains are, we need to find out if this is a risk worth taking. So the way we're going to look at that is how we can minimize the amount of risk and make sure that we can enable our students to have an interesting and exciting science curriculum. For me, we can't avoid this. This is an unavoidable lemon. It will explode in sugar, but that's what we want. We want them to be able to see this bright, exciting, and violent demonstration of energy. So we need to make sure that we're controlling the explosion instead. We're going to set up 4 screens, each one around the experiment, so that if anything does happen, it will just hit the screen instead of exploding all over the children. We're going to make sure that our melt is removed from the heat as soon as we start the experiment. We don't want there to be any chance of this blowing up at all. And like I said, we need to make sure we're using the right gummy bear. If we use the sour gummies, it's going to go crazy. For our second one, can set fire to the fume hood, what we need to make sure we're doing is making sure we're not setting fire to the fume hood. Don't do it in the fume hood. But it is going to produce noxious gases. It is going to produce things that can hurt those asthmatics. We need to make sure that we're opening the windows, that we've got lots of fresh air coming through. If we don't, then the smoke won't dissipate and it can cause breathing problems to those with asthma. So let's make sure that we're thinking about all those lemons. That we can't do it in the fume hood, but we can do it in the open lab and make sure that we're opening the windows so that our students are being safe. And finally, what I said about the sour gummies, we just make sure we don't use them, yeah? This was so quick in order to just plan a very, very, very dangerous experiment. I hope this makes you think about health and safety in a little bit of a different light. Remember, we should be thinking whether or not this is a risk worth taking. We need to make sure that we're providing a safe, yes, but not sterile curriculum. Just remember, think about the lemons.